So in 10.1, we did probability. In 10.2, we're going to do experimental probability. And experimental probability is comparing or writing in fraction or percent form the amount of times that it did happen out of the number of trials. So you have a formula for this, and that is the probability, so P equals the number, oops, that's an M. Number of times it occurs over the total number of tries. Okay, so if you are kicking a ball to try and make a goal, and you want to find the probability or the likelihood that you are going to make a goal, let's say you do it 50 times and you make it into the goal 25 out of the 50 times. You would put your probability equals number of times you actually made a goal, which was 25, out of the number of times you kicked it in, or kicked the ball, which was 50. Well, we know that that's going to equal 1/2 or 50%. Okay, so the probability of you making a goal when you kick the ball is 50%. Okay, let's look at some of the other examples they have in the book. So the first example is saving. So he is a goalie. Yep, field hockey practice, Tanya. So she made saves on 15 out of 25 shots. Based on the numbers, you can estimate the probability. So we know that P equals number of times the event occurs. So the event in this case is the saves. So saves over total shots. So P equals 15 over 25, which we can simplify that fraction. 5 goes into both of these, 3 and 5 times. And then to put that into decimal form, that's going to equal 0.6, and we know that that's going to equal 60%. So the experimental probability that Tanya will make a save on the next shot is 60%, or 3/5, or 0.6, depending on what the assignment asks you to write it in. They may even ask you to write it in all 3 ways. We'll talk about that at the end of the lesson. So the next example is we have somebody who was recording the temperature every day. So he's got 3 weeks, so 21 days of temperature recordings. And it says, what is the probability that the temperature will be above 75? So what he does is count the number of days that the temperature was above 75. So P equals temps above 75 degrees over total days. So P is going to equal, if we count it out, it's going to be 14, I believe. 14 days that were above 75 out of 21 total days, which both of these are divisible by 7. So we're going to 2/3 is the fraction. And I think at one point in time we wrote down common equivalent fractions, decimals, and percents. So we know that this is about 66%. Okay. So then the next question is, what is the probability that the temperature will not be above? Well, we remember from last lesson that your 2 P's, so this being above, so plus your P of below has to equal 1. So we already know that this one is 2/3. So 2/3 plus this unknown equals 1. Well, 2/3 plus what equals 1? Well, that's going to be 1/3. So we know that the probability of it being below 75 is 1/3, or 33%. Okay? So these are the two formulas you're going to need for your assignment. It's not a very long assignment. It's just 1 through 9 all. So 1 through 9 all. And it looks like some of them are going to ask you for all three things. They're going to ask you for a fraction, a decimal, and a percent. Some of them are just going to ask for a fraction. So make sure you're reading your directions closely and you're looking at what formula you're supposed to be using. So if you have any questions, now is the time to ask. Otherwise, you can go ahead and get started on your homework.